Hi there, this is Professor Eckhouse, and I'm going to talk today about simplifying roots and rational exponents. So we talked about this in 11.1a, what these things are, and now we're going to talk about simplifying them. All right, so we're going to start by just simplifying square roots, remembering that radical expressions are expressions that contain radicals. It's not an equation, it's an expression, which means there's no equal sign. We're just simplifying. You see an equal sign here, but it just means we're doing something to it. We're not solving for x. Okay, we're just simplifying it. So to simplify, we generally use the exponent rules. So there's an important exponent rule that we need to know, and that is xy to the a means x to the a, y to the a. In other words, the a applies to both. Now this is different from x plus y to the a. So I'm used to saying squared to the a. It does not mean x to the a, y to the a. It is not x to the a plus y to the a. Not. Okay? Don't do that. All right, so 5x squared is 5 squared times x squared. In other words, this squared applies to both, so it is 25x squared. All right, the next one, 5x to the 1/2, is 5x. What it means is square root, right? Square root. So let's think about it. I'm going to get rid of that because we want to work this out. So 5, this means 5 to the 1/2 times x to the 1/2. Right, that's both. So it is, like I said, the square root of 5x, which is also the square root of 5 times the square root of x. All those things mean the same thing. Okay, so I've got an equal sign between them because I'm saying they all mean the same thing. Square root of 5x then is the square root of 5 times the square root of x, like I said up above. Okay, so you just have to get fluid and flexible in the way you look at all of these things meaning the same thing, different ways to express them. So here's the rule for us. The square root of AB, this right here, square root of AB is the square root of A times the square root of B. So if you have something like square root of 100, here, it means the square root of 10 times the square root of 10. And the square root of 75 means the square root of 25 times the square root of 3, because 75 is 25 times 3. Okay, so you can break any of these up into their factors. All right, so square root of 63, let's break it up into something. So try to think if you can think of a perfect square in 63. And I know that 63 is 9 times 7. So I'm going to say that this is then the square root of 9 times 7, which means, according to this rule right up here, that we've got the square root of 9 times the square root of 7. Square root of 9, this portion right here, is square root of 9 is 3. And we're only going to use principal roots, so only the positive ones on these, on simplifying, just like last time. So square root of 9 is 3 times the square root of 7. So square root of 63 simplifies down to 3 square root of 7. Right, so these get more complicated. So I would recommend from here on, as you watch the video, to try each one before I show you how to do it and see if you get it right. And what you don't get right, try to figure out why you missed it. All right, square root of 32. Think of a perfect square in this. So I know 16 times 2 makes 32, and 16 is a perfect square. So let's use that. So 16 times 2. So if you can find a perfect square, that's what you should do when we're simplifying these. So that means the square root of 16 times the square root of 2. You don't have to take all these steps like this one here is so similar to the one before. Lots of times people skip this step right here, but I just want to show you the square root of 16 is then 4 times the square root of 2. And if it's written side by side like that, it means times. All right, try this one. All right, so hopefully you paused and gave it a try. If you didn't, do give that a try. Square root of 50, if you can think of something that's a perfect square that goes into 50, then go ahead and factor it out. And I know 25 times 2 makes 50. So I'm going to say square root of 25 times 2. Okay, so they're still under the square root sign, which means the square root of 25 times the square root of 2. And the square root of 25 is 5. So that becomes 5. And so I could highlight that and say those are the same thing. Make sure if I've lost you at all here, make sure that's the same thing. The square root of 25 is 5, right? So we simplify it and say 5, and it's still multiplied times square root of 2, so 5 square root of 2. All right, last one. In this section, see what you can do with that. All right, 128 is, look for a perfect square in it, and this is where knowing your perfect squares really comes in handy. 64 times 2. So this is the square root of 64 times 2. So that is the square root of 64 times the square root of 2. And I know that 64, square root of 64 is 8. So 8 and square root of 2 doesn't simplify anymore, so 8 square root of 2. All right, so let's come to the next section here. Oh, I've got a big empty spot. All right, so we've got the square root of x to the 4th y squared. What are we going to do with that? So there's a number of ways to think about this. So x to the 4th is, let me show you a couple ways here. X to the 4th is x squared times x squared times y squared. Now, every time we have a square, because remember the square root of x squared is x, the square root of y squared is y, and so forth. Okay, so now if I took the square root of x squared times the square root of x squared times the square root of y squared, I would get x times y. This is this one. This is this one. And this is this one. So x times x is x squared, and I get x squared y. Okay, so we could also use the exponent rules for this. So this is x to the 4th y squared to the 1/2 power. So remember the radical sign means to the 1/2 power. All right, so if you know your exponent rules, they really help with this. So x to the 4th to the 1/2 times y squared to the 1/2 is what we get here. All right, so let's work on the x to the 4th to the 1/2. All right, so that part right there is going to be x to the 4 times 1/2 is 4 halves. Well, 4 halves is 2, right? So this becomes x squared. So 1/2 of 4. And then we've got 1/2 of 2 here, so this is y to the 2 over 2, which is just y. So again, we get x squared y. Whichever way you want to do it, breaking it apart, looking at all the pairs, every pair is going to be a squared, and when you take the square root of it, you get itself. Okay? All right, so let's try this next one. So I'll do it the first way. We're going to break this up into the square root of 25 times the square root of x to the 6th times the square root of y squared. All right, so the square root of 25 is 5. The square root of x to the 6th is like x to the 6th to the 1/2 power. Or you can think of it, where could I write this? Let's go over here. Or you can think of this as x squared times x squared times x squared, all under a square root. So you've got the square root of x squared times the square root of x squared times the square root of x squared, which becomes x times x times x. All right, so that's another way to look at it. But what I'm doing here, right here, is x to the 6 over 2, which is x cubed. So here we get x cubed, and here we get x cubed. It doesn't matter which way you think about it. It means the same thing in the end. All right, so square root of y squared then is y. So now this whole thing, let's write it all together. We get 5x cubed y. So I want you to notice this. Let's just write it right below. We get 5, this equals 5x cubed y. What happened to the 6 and what happened to the 2? it's just half, right? So if it's an even number, it's just going to be half. All right, so why don't you try that one? See what you can do with it. There's a couple of odd numbers, so think about what you might do. All right, so I know that when I take a square root and it's even, like what I just set up above, I'm going to get an answer. 6 becomes thirds, squared becomes 1. So I'm going to have to break this up a little bit differently so that I can pull x squareds out of it, okay? So I'm just going to do one sign real quick so I don't have to write so many. So let's deal with this x cubed. So that is going to be an x squared, but then there's an x left over. That's x cubed. All right, so that is going to be this portion here. All right, now let's do the y to the 5th. So I get y squared times y squared. That's y to the 4th so far. So I have one more to go, and now I have y to the 5th. All right, so that is the y to the 5th. All right, then I've got z to the 4th, so I get z squared and z squared. That makes up a z to the 4th. All right, so that is our last portion there. Whew, okay, so now we've got an x squared and an x. So do we want to write every single one of these out? I will do this one time. This is long if you do it with a radical over each one, but we've got square root of x squared times the square root of x times the square root of y squared times the square root of y squared times the square root of y times the square root of z squared times the square root of z squared. You will get faster at this and not have to do all of this, because every time you see a square and you're square rooting it, right, you can bring it out and it becomes x. But this doesn't change. It's still square root of x. All right, now this one, we see a y squared, and it's going to become y. Another y squared, square root it, it becomes y. All of these are multiplied together. And the square root of y, it can't go any further, so it's just square root of y. All right, now the z squared, square rooting it, turns into z, and again with this one, z. So that one was that one. All right, so now we're going to have to combine all of this. I'm showing you the very, very, very long way. You will get better at this and see how many pairs are in each one, and you can just pull them out. All right, so now everything that is outside of a square root, I'm going to combine. So I've got an x, I've got two y's, so y squared, and I've got two z's, z squared. Now underneath the radical, I've got an x and a y, or you can just write xy. All right, and that is the final answer. That's simplified. All right, the next one. All right, so I'm square rooting. So remember, this is a 2 right here. So that means if I see evens, I just divide them by 2. And you can go do it the long way if you want to, but this video will be very long if I do them all the long way. But this one right here I'm going to have to pull the squared out of the cubed. Okay. All right, so I'm going to square root the 4, and I get 2. I'm going to square root the x to the 8, 8 divided by this 2 right here. So let me write that down actually. So I'm going to have x to the 8 over 2. And then I have y to the 6 over 2. And then I have an odd number of z's. So I get z squared times z. Okay, so I'm still going to leave that inside so we can figure all this out. All right, one step at a time. So I've got the 2. I've got x to the 8 over 2 is x to the 4. Y to the 6 over 2 is y cubed. And again, you could go write out every y squared. There's 3 of them, right? Y squared times y squared times y squared. So you get 3. Y to the 3rd. All right, now the square root of z squared is z. And what's left underneath is just 1z by itself. So think about it. That was the only odd one. And so that's why we end up with 1 still stuck underneath. Okay, so try this. All right, so using those rules up above, we've got 49 to the 1/2 times x to the 6th to the 1/2. Well, 49 to the 1/2 is the square root of 49, which is 7. X to the 6 to the 1/2 is, you might be able to do that in your head now, but if not, just write it like that, 6/2. So we've got 7 times 6/2 is 3, so 7x cubed. You can also do it with radicals. So you could rewrite this, if you wanted to, as 49x to the 6th square root and use it with radicals if you prefer. All right, give this one a try. Before you begin, notice that this exponent is even and this one is even, so when we square root them, it's just half. All right, so the 81, square root of 81 becomes 9. The square root of x squared, x to the 12th. So remember, this is a 2. So we're going to take x to the 12 over 2 and y to the 8 over 2 because of we're square rooting it, so it's over 2. And we learned that last time. So we get 9x to the 6th, y to the 4. And again, you could write all this out, right? You could have square root of 81 times the square root of x squared times 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 x squared. But who really wants to do that, right? So every one of those would come out, and I'd get 6 x's. So x to the 6th. Whew, too long. So just use the rules, and that'll get you there faster. All right, so now we're going to look at cube roots, and if you understand the rule of what we just did above, the cube roots is not quite so hard as it may look, but I'll go about it the long way first, and then we'll see where that leads us. All right, cube root means that we have got to find sets of 3 things, right? So remember, if we've got x cubed and we cube root it, we get x. So if you think about it, what that means is the cube root of x times x times x. That gives me x. So what if I had 4 x's? So if I had the cube root of x to the 4th, well, I would have the cube root of x times x times x times x, right? So every time I have a set of 3, or x cubed, that together will become x when I take it out. But I'll still have this left over, and it's still the cube root of that. Okay, so x cube root of x is what that would be. So, all right, so continuing on with this. So we've got 32. That is not a perfect cube. But I do know that it is 2. I think I may have done this wrong, so I'm going to ignore my notes. 32 is, do we have any perfect squares in there? Well, I have 16 times 2. Look at that, 16 times 2. We're looking for perfect cubes, sorry. All right, let me try that again. I'm looking for perfect cubes. So let's just break it down. And I've got 16 times 2, and then 16 is 2 times 8, and then 8 is 2 times 4, and then 4 is 2 times 2. Oh, right, that's 2 to the 5th, isn't it? So let's try that. So we've got 2 times 2 times 2 times 2 times 2. That's 32. And look, I have a set of 3 of them right there. So when I cube root that, that is going to come out to be 2. And the rest is going to be the cube root of 2 times 2, which is 4. So that's where that goes right there. All right, so now I've got the cube root of m cubed. Well, we know that that just gives us m. Cube root of m cubed is m. All right, then we've got the cube root of n to the 6th. Well, that means n to the 6th means cube root of n cubed times n cubed. That's n to the 6th. All right, so that means that this one comes out and becomes n, and this one comes out and becomes n. So these are like a puzzle. Just keep going until you get it all out of there. So I've got 2, and then I've got an m, and then I've got 2 n's, so n squared, and then we've got the cube root of 4. All right, so let's move on from there and try another one. 54. All right, so let's just factor this. And I get 54 is going to be 9 times 6. 9 is 3 times 3, and 6 is 2 times 3. I'm going to turn on my focus to present so it doesn't keep making noises. All right, so we've got 3 times 3 times 2 times 3. Oh, look, I've got 3 3s. Look at that. All right, so let's think about that. So I've got 3, cubed, and I've got 3 times 3 times 3 times 2. That's my number portion, okay? And then I've got x, I'm taking the cube root, so I want to pull out cubes. So let's write it like this, x cubed times x. That's x to the 4th. So stop and think about it. That's a 1 right there, so that means x to the 4th. All right, let's do the same thing with the y to the 7th. Think about how many sets of 3 come out of the y to the 7th. So we've got y cubed times y cubed times y to the 1. That gives us 7 y's. All right, so now let's get to work on this. So we've got a set of 3 right here, and I've got cube root. So that's going to come out as 3, and then I'll still have a cube root of 2. So everything's multiplied. There's no addition. We're just going to, everything's multiplied. So we can pull everything apart and put it all back together. If it's under the root, then the radical, we're going to put them all together into the radical. And if it's not under the radical, we'll put it together outside the radical, okay? All right, so now we've got a set of 3 right here, x cubed, and we're taking the cube root, so then mean that comes out to the outside as x. All right, what's left on the inside of the cube root for this one? That's just an x to the 1. All right, so in the next one, I've got this set of 3 y's and this set of 3 y's. That means we've got 2 y's. I'll write it the long way, though. So we've got y times y. You could say y squared if you wanted to. All right, and on, so that's that one, and that's that one. And then we still have this y to the 1 left. So that's going to be cube root of y to the 1, so just y. All right, so all the pink stuff goes on the outside. So that is going to be 3 times x times y is y squared. Underneath, we're going to have the cube root of 2x y. Okay, so that's the final answer. Woohoo! Just a big puzzle. All right, so continue on. Give that one a try. All right, so negative. So we can take the cube root of a negative, remember? So this is going to be negative 3 cubed, right? That's what that whole thing is right there, negative 3 cubed. All right, so let's write that down. All right, so we've got cube root of negative 3 cubed times the cube root of x to the 5th. So I'm looking at the x's right now. So let's pull out how many sets of 3 can we pull out. So we've got getting late here in my house, x cubed, and then I've got an x squared. So that makes x to the 5th. And this is the set of 3 that I'm looking for, just like I'm looking for a set of 3 here. All right, so then I've got y cubed, cube root of y cubed. Perfect, that's all I need. And then I've got cube root of z to the 6 is z cubed times z cubed. How many sets of 3 can we get? So here I've got a perfect set of 3, and here I've got 2 perfect sets of 3, which is z to the 6, with nothing else left underneath. So let's pull out everything that can come out. So this one comes out, and I get negative 3. This one comes out, and I get x cubed, and I still have a cube root of x squared left underneath there. All right, so now the next one, I've got a y cubed cube root, so that becomes y. That's that one right there. And then I've got 2 here, which I could write as z squared if I wanted to, because I've got 2 of them, but I'll just take it the long way just so I don't lose anybody. All right, so I've written all the pink ones on the outside, and the purple ones are still stuck underneath. So go collect all the pink ones. So we've got negative 3, x cubed y z, and there's two z's, so z squared. And then I've got cube root of x squared. All right, one more. Give this one a try. All right, remember -8 could be -2 cubed because we're looking for cubes. All right, so let's write this as the cube root of -2 cubed. So there's my perfect cube I can pull out right away and say -2. All right, so this takes a plan. You got to think about this as you go. So we've got cube root of x to the 6 is x cubed times x cubed. So 2 perfect cubes there and there. In other words, x squared. All right, so this becomes x and this one becomes x squared. All right, and the last one is going to be, now how many perfect cubes can you pull out of y to the 5th? So you've got a y cubed times a y squared. Okay, so we're going to pull this out. So it becomes y when we cube root it. I forgot to write that. And then the y squared is still stuck underneath this cube. There's not enough of them to come out. So we've got y squared right there. All right, so see if you can pull that all together. You can pause it if you want to and see if you can pull it together correctly. All right, so I get -2 x squared y cube root of y squared. That's all one big term. All right, so I've got simplifying a 4th root. I think I've got at least one 4th root here. Yeah. All right, so simplifying using a 4th root, I just wanted you to see it. There may be one problem like this on the homework. But basically you're looking for sets of 4 instead of sets of 3, right? So think about it, x to the 4th root would be x. So 4th root of x to the 5th is going to be the 4th root of x to the 4th times x to the 1, which is going to be, x times the 4th root of another x. Okay. All right, so let's try simplifying this one here with roots. All right, so we've got the 4th root of 81 times the 4th root of x to the 12th. How many sets of 4 go into that? How many sets of 4? So we've got x to the 4th 3 times. All right, and then we've got y cubed. There's not enough in there to come out at all. There's not even 4. All right, so the 4th root of 81, maybe you did not know, is 3. The 4th root of x to the 4th 3 times is going to be 3x cubed, right? There's 3 sets of them. So this could be written as x to the 4th times x to the 4th times x to the 4th. So just like before, every time you have an x to the 4th and you're 4th rooting it, or x to the 3rd and you're 3rd rooting it, you can pull out that 1x. That's what you get. So I got 3 of them, so I get x cubed. And then the last thing is going to be that 4th root of y cubed. All right, so the next one is simplifying using exponents. So I would have 81 to the 1/4 and x to the 12/4. Okay, so we learned that last time, 12/4. Let me scoot this together a little bit so we can get back up where we can see that. All right, times x to the 12/4 times y to the 3/4. Okay, so this was that rule. Don't forget the rule when you've got, let's see, how can I do this? If I've got x here and I've got a here and b here, then that is x to the a over b. So make sure you've got that rule straight from last time. All right, so 81 to the 1/4 again is 3. X to the 12/4, 12/4 reduces to 3. 12 divided by 4, x cubed. And y to the 3/4 we would rewrite as the 4th root of y to the third. Okay, so you can always think of these with the exponent rules. If you can do the exponent rules, it will save you on these. It makes it so much easier. I think it's easier than looking at it with the roots. All right, so simplify using roots. This is a challenge problem, okay? So where should we start? All right, so I've got 10b to the fifth c cubed on top and a c on the bottom. And this is all one thing. So let's go deal with this cube root of 8b to the 6c cubed by itself just for a moment. So let's do this with exponents. So 8 to the 1/3, b to the 6th to the 1/3 means b to the 6/3, and c to the 3/3. Well, look how much that simplifies. 8 to the 1/3 is the cube root of 8, which is 2. b to the 6/3 is b squared, and c to the 3/3 is c. So suddenly on the bottom I have c times 2 times b squared times another c. All right. And my fifth is really messy, so I'm going to fix that. All right, b to the 5th. All right, so now I've got 10b to the 5th c cubed over 2b squared c squared. All right, so now 10 over 2 is 5. So people miss this a lot on the second test. So this is 5. And then I've got b to the 5 minus 2 is the rule. And c to the 3 minus 2. The exponents get to subtract. All right, so we've got 5 to the b cubed, c to the 1. All right, so that's the final answer on that. All right, thanks for watching.